Okay, quick starter for you today. Two bracket questions. This is a single bracket to expand. This is a double bracket to expand. Pause and have a go. Okay, so here I'm just multiplying both things in the bracket by x. So that's x times x and x times 5. Sorry if my 5s are sometimes a bit quirky, I apologise. And then I'm hoping you gridded this one out or used whatever strategy you are used to using. I think having a strategy which reminds you there are 4 sums to do is really important. So, and then by now hopefully you remember peanut. It's because that's shaped like one of those peanuts you get in the shells. That's why it's called peanutting. So you get x squared minus 7x plus 5x is minus 2x. And don't forget, to get that number you multiply, don't add. So that's minus 7 times plus 5 is minus 35. Well done. Let's get on with the lesson proper. Hi Year 11. Here's the second lesson then in this sequence on speed and density. Today there is a question that I'd like you to submit at the end of the video. Just a word about submissions. Lots of you are submitting pages and pages and pages showing me your notes. It's brilliant. Brilliant to see your notes, it's great. However, I would be grateful, just because of a workload issue, if you could just submit the specific question that I ask for. That would just make things a bit easier for me, and I'm really keen to feedback to you individually about that, but it helps if you're just submitting the questions that I ask. I've been delighted to look at notes, and so I think I'm now clear on who is making good notes and who isn't, so thank you for that. But I think now if we could just make sure we're just submitting the answers to questions, which several of you are already doing, and that's brilliant. I'm very grateful. As I said, there's a submission question at the end of the video, so make sure you get to the end of the video so you know what it is that I'm asking you to do and submit. All right, so here we go. We're asked, we've got 3 roads here. Which of the 3 roads takes the longest time? So I've got my speed is distance over time formula. I know if I've multiplied both sides by time, I get a formula for distance. And then if I divide both sides by speed, I get a formula for time. And I was able to do that far quicker than I could have drawn a formula triangle. So I know that I need distance divided by speed. So go on, see if you can pause the video and answer that question. Did it again, did it last lesson, didn't I? I got it the wrong way around. Really important that you get it the right way around, distance divided by speed. So this was half an hour, 30 minutes. I chose to leave this as a fraction, 2/3. 2/3 of an hour is 40 minutes. And this is 3/4 of an hour, which is 45 minutes. Now it doesn't actually ask for the actual times, it just says which of the 3 roads takes the longest time. So the answer is road C. Really important that you answer questions like that. Okay, the question develops and talks about Jake and Adam. And Jake and Adam are travelling along this road network. So let me zoom out a little bit so we can see it all. Sorry, there we go. Just going to refocus. So we've got 2 journeys here, 2 journeys. Jake and Adam travelling from X to Y. And Jake travels along road B and Adam travels along road C. So I'm gonna sort of try and squeeze it in up here. Whenever we've got these 2 journey problems, remember for Jake we've got speed, distance and time. And for Adam we have speed, distance and time. Remember, Jake is travelling along road B, which is 20 miles long. This is the average speed. This isn't the speed that he travels along. And Adam is travelling along road C, which is 30 miles long. So just pause the video at this point and see how much information you can fill in that little bit of that little table there. Sorry, I haven't set this out very clearly. That's the answer to the previous question. That's not part of this answer, is it? So we know that Jake travels 10 miles an hour faster than the average speed. The average speed on road B is 30, so he's travelling at 40 miles per hour, and the distance is 20 miles. All we know about Adam is he travels along road C, and that's 30 miles long. We know their times are the same. It tells us that here, but we don't know either time yet. But I can work out this time, can't I? Distance divided by speed. I can work out Jake's time. So 20 divided by 40 is 0.5. It takes him half an hour. So I therefore know, because it says they take the same time, that it's half an hour for Adam as well. The question is then, what's Adam's speed? Is it faster or slower than the average speed? The average speed on road C is 40 miles an hour. Is Adam's speed faster or slower than that? Well, I've got all the information I need to work it out. I know what speed is. Speed is distance over time. So I'm just going to do 30 divided by 0.5. Which is 60 miles an hour. Does Adam travel faster or slower than the average speed, and by how much? Well, the average speed is 40 miles an hour on road C, so Adam travels 20 miles per hour faster. So these two journey questions, where you've got one person's journey, speed, distance, time, and someone else's journey, speed, distance, time, are very common. And sometimes you then have the overall journey, if it's a journey from A to B and then B to C. We did one of those last lesson. Okay, so the next couple of questions are relating to density. So density is often taught along with speed because the formula for density also involves three quantities. So density is mass divided by volume, and I'm sure you've done that in science. So I know if I multiply both sides by volume, I get a formula for mass. And if I divide both sides by density, I get a formula for volume. And so that's my my three part sort of starter to all this question, because I always like to have the three formulas written out. I don't yet know, I haven't looked at the question yet. Am I going to be asked to find a density, a mass, or a volume? Let's have a look. Silver has a density of 10.5 grams per centimetre cubed. Silver chain has a mass of 52.5. Work out the volume. Right. I need to work out volume using that formula there. Got to check my units. So the density is in grams per centimetre cube. So my mass needs to be in grams. Bingo. And so the volume is just mass divided by density. And if I do that sum, that comes out as 5. And 5 what? Well, this is a volume. Density is in grams per centimetre cube, so that's going to be centimetre cubes. Right, a little easy. So let's try something a little bit more challenging. Here's one that I'm going to get you to help me with. So this is a cross-section of a prism. So a prism is one of those shapes that has the same cross-section running all the way through. So this is like an L-shaped bar. And notice that we're given its dimensions in centimetres, but it's actually 2 meters long. So this is not to scale, but you know, it's 200 centimeters long. Now, I'm given the density of the metal and asked to work out the mass. So hang on a minute, density is mass over volume, multiply by volume. Density times volume is mass, divide by density. Right, I want to work out the mass, so I need the density, bingo, and I need the volume. I haven't got the volume, have I? Got to work out the volume. Do you remember how we work out the volume of a prism? It's the area of the end multiplied by the length. So I'm going to get you to pause the video at that point and work out the volume. Area of the end, I guess you're going to break it into two rectangles, multiplied by the length. Remember, the length because the area, the dimensions are in centimetres, we're going to use 200 as the length. It's 2 metres, which is 200 centimetres. So pause the video, work out the volume for me firstly. Okay, so I split it up like this. You could have done it differently, couldn't you? So that bit's 7 times 2, which is 14 centimetre squares. That length there is 7, take away 2, so it's 5 times 2, so that's 10. So the area of the end is 24 centimetre squares, and the volume, therefore, area of the end multiplied by length, is that. Okay, pause again and bring it home for me. I want the mass. This is the formula for mass. You've now got all the information you need to finish that question. Okay, so the mass is density times volume. The density we're given in the question, that's in grams per centimetre cube. So the volume needs to be in centimetre cubes as well. It is. And that means that the answer is going to be in grams. Just a quick check, do they want it in kilograms? They don't. If they did, then it's 38.4 kilograms, because 1,000 grams gives me a kilogram. Well done if you got that. Okay, part A. Here are the formulas. You're asked to work out the volume of copper. Have a go at part A only. Pause the video, come back when you've done that. Okay, volume is mass over density. The mass of copper, 180. The density of copper, 9. So 180 divided by 9, which is 20. 20 what? Well, it's volume. If I look at the density, that's grams per centimetre cube, so that's centimetre cubes. So what we've got in part B is like the 2 journey questions. So we've got 2 materials, copper and zinc, and we're combining them to make what's called an alloy. I'm sure you know that from your science. So what I've got is this sort of structure, which we met when we were doing 2 journey questions. This is like the question where we had a journey from A to B, a journey from B to C, and then the overall journey. So my first job is to fill in everything I know from the question. I'm actually being asked to find this. Okay, so without doing any more calculations, let's just fill in everything we know from the question. So pause the video, see if you can fill in the blanks as far as possible. So I've filled in the numbers that we've got so far. So the densities we're given, and the masses we're given, and we calculated the volume of copper in part A. So where do we go now? This is where it would be so much better if we were in class, but I hope you can see that if I want to work out the density of the alloy, which is both of these metals combined, I need to know the mass of the alloy and the volume of the alloy, because density is mass over volume. The mass of the alloy, well, I know that because it's going to be the result of mixing these 2 metals. So that's going to be 285. The volume of the alloy will be the combined volume of the 2 metals. Now I know the volume of copper, I did this calculation here. So if I repeat that calculation for zinc, if I do mass 105 divided by density 7, I get 15. 15 centimetre cubes. So the volume of the combined alloy will be 35 centimetre cubes. So density is mass divided by volume, 285 divided by 35, and not a very nice number, so I'm going to round it to 2 decimal places. Now that's in grams per centimetre cube. Density means every gram, that's how much, sorry, every centimetre cube, that's how much it weighs. I've completed that question. Okay, time for me to stop blabbering on and to give you a chance to do one. So this isn't the question for submission. We're going to do this in the lesson. So this question is very similar to the one we've just done. It's 2 metals, lead and tin, being mixed to make an alloy, and we're asked to work out the density of the alloy. So I'm going to pause and come back in a minute with the complete answer. Have a go at it yourself before doing that. We've got a problem, haven't we, with this question in that the volume, which we work out by doing mass divided by density, doesn't give you a nice round number. So you've got a couple of options. I mean, rounding is never the ideal thing to do within a question, but because we're asked to give the answer correct to one decimal place at the end, I'm pretty safe if I go my intermediate values to two decimal places. However, some of you I know will be able to use the memories on your calculator and store the exact answers to those questions. And that's certainly something I will be showing you when we're back in class. So the overall volume is those two added together. The overall mass are those two added together. So the density is mass divided by volume, and I incorrectly rounded it to 8.41 because I hadn't spotted that, but there we go. 8.4 grams per centimetre cubed is the answer. Well done if you got that correct. Okay, so that's all the practice I'm going to do. Here's your submission question. Actually, this is a lot more straightforward because you don't need to consider the overall journey. You're just looking at this as two separate journeys. But try and set it out in the way that I've encouraged you to do so. And remember that it wants the answer in minutes, even though the speed's given in miles per hour. I look forward to getting your solutions to that. Remember, it's been great to see so many people show me their notes, but just to help me with my workload, I'd be grateful if you could just submit your answer to that question only. Okay, have a good weekend. Take care.